You're listening to Let's Talk Creation, the science podcast that's just for you.
Well, it's fabulous to be back for another episode of Let's Talk Creation with Paul Garner and Todd Wood. I'm Paul Garner.
And I am Todd Wood.
As always, if you're enjoying the podcast, do remember to subscribe and to like, share our episodes, tell your friends, leave us a review, add your comments to our YouTube videos, all of those things. That's really great. We love to hear from you. Today, Todd, we are going to continue our deep dive into radiometric dating. As our regular viewers and listeners will know, this is a kind of occasional series that we've been running. And what have we done? The first episode we kind of looked at some of the general principles of how dating methods work. Then we had an episode with a nuclear physicist, Dr. Ben Clausen, who helped us to understand radioactive decay, and he has experience in using radiometric dating on rocks, so he was able to talk us through how that's done. And then I think we had an episode, the last one that we did in this series, which was about the RATE project.
Right.
Because I think people were eager to hear, having kind of established, the problem, the challenges of radiometric dating, people were eager to hear about a creationist response. So in episode 40, we began to think about the RATE project. Now, just to remind our viewers and listeners, RATE was a multi-million dollar, actually $1 million project. I was going to say multi-million. I don't think it was. It was about $1 million, wasn't it? I think they spent on the RATE project. It was basically a project that run by the Institute for Creation Research and the Creation Research Society, with a number of scientists involved, and it was basically to develop a creationist understanding of radiometric dating. And the RATE project came to a few conclusions, which we talked about last time. The first conclusion was that there has, in fact, been a great deal of radioactive decay in the history of the Earth. And this is evidenced by various things that we talked about, especially fission tracks and radio halos. These are physical marks of damage, radiation damage, that you can actually see in the rocks. You can see them under the microscope.
Right.
And they give evidence of at least millions, hundreds of millions of years worth of nuclear decay in the Earth's past. Secondly, the RATE group concluded that radioactive decay rates in the Earth's past seem to have been accelerated, possibly during more than one episode, maybe during Creation Week and particularly during the flood. And again, they pointed to various lines of evidence that seem to point towards this conclusion, including looking at concentrations of helium in the crust of the Earth. Helium is a byproduct of uranium decay, and they were able to argue from the leakage rate of the helium that an awful lot of helium had been produced, but probably not all that long ago, and that seemed to point to an episode, a kind of burst of radioactive decay. And some other evidence, polonium radio halos, these sort of short-lived isotopes that produce halos that have some interesting timescale implications, both for the formation of the host rocks, but also for timescales of nuclear decay. So there's been a lot of radioactive decay. They think that decay has been accelerated in the past. And then the third conclusion was that there are systematic discordances or disagreements between the results of different radiometric dating systems. So in other words, when you date a particular rock unit with multiple different radiometric dating methods, those radiometric dating methods give different results. They disagree with one another, but more interesting than that, they also actually disagree systematically. So there is a kind of predictable disagreement And they argued that this was a clue, perhaps, to how radioactive decay had been modified in the past. So that was kind of where we left things last time. We introduced the rate project, but of course we're aware that not everybody was happy with the rate project. That inevitably there was pushback from critics and from anti-creationists, and a number of criticisms have been voiced about the rate project. And we thought that it would be good today to have a look at one of those responses and dive into it and have a look at what the objections were. So, Todd, you came across this article. Why don't you tell us about the article and the author of the article?
Right. Yeah. So, and to put this again into context, literally before the rate episode even aired, we got an email saying, "Are you going to give the other side and the criticisms of rate?" So, here it is. At least here is one of those possibilities. Now, like you said, there were lots of people who were unhappy with rate, and there were lots of reviews, critical reviews of rate. I just picked one that I happen to remember. So if you're listening and you think this is just low-hanging fruit, it's not a very good review and we could have done better and there were much better criticisms, you're probably right. Cool. I just picked one that I knew. So if we need to do better, we will definitely do better. And if you know of a real hard criticism of rate that's really more than what we're going to talk about here, then sure, pass that along. We'd love to know what that is, and we'd love to have a chat about it. But the one I knew about was published in the ASA journal, Perspectives on Science and the Christian Faith. Now, for those of you listening, let me introduce the ASA. The ASA and its history with young age creationism, let's call it fraught. So the ASA is older than the Creation Research Society, and there's a good reason for that. And the reason is that the organizers of the American Scientific Affiliation did not feel, even though it was a organization for Christian people who happened to be scientists, they did not feel that it was important for them to take a hard stand on the age of the earth. And so individuals like Henry Morris and other creationists at the time became increasingly dissatisfied at the sort of critical stance that various ASA members were taking on young age creationism. And so they left to form the Creation Research Society, which then is one of the sponsors of the RATE project. So there's this organizational history going on here. This may not be a thoroughly unbiased review. Just be aware of that. Today, as we'll see here, the ASA, and I think they still continue to do this, they maintain that they do not have a position on the age of the earth, but I cannot remember the last time I read an article in PSCF, their journal, that was sympathetic to young age creationism. Occasionally I will see creationists publishing there, but they are doing so not as creationists publishing a creationist paper. The last time I tried to publish there was, a couple of years ago, a year ago. It was not a paper that advocated young age creationism. It was a paper that advocated respectful dialogue between creationists and evolutionists. And it was rejected without review by the editor, who said young age creationism is simply mistaken. So there's no reason to publish this paper.
Okay.
So, yeah, just so we all know where we're coming from, there's all my cards on the table. You can see that. I don't think there's a lot of love lost between young age creationists and the ASA. So keep that in mind. So So this review was written by a guy named Randy Isaac. Randy was the, let's see, how was he described? The executive director of the ASA. He was basically employed by the ASA to handle the business of the society. So the ASA has a president that's elected. The executive director is a hired staff position. And Randy, I looked him up. He has a PhD in physics. So he is qualified to comment on physical issues. And but his career was in technology mostly before he came to the ASA as executive director. So, he's probably as qualified to comment on this as I am qualified to comment on evolutionary biology. So I'm not gonna question his credentials. They seem quite good. They are at least as good as mine are in my areas of interest and expertise. So there you go. So this review article is 4 pages. 4 pages of a nearly 800-page book, which is the second rate book that describes the results. I also note here that he doesn't have a single citation in this thing. So this is more of a review essay than it is an in-depth critique. So I wish in some of these places that he would have said more. But let me just highlight here a couple of his comments. With regard to the helium diffusion that you mentioned, Randy says the data presented were taken. The data presented were taken in conditions of laboratory vacuum, and actual diffusion rates in field conditions are known to be considerably lower, by as much as a factor of 1,000 or more. The rate researchers claim to have meticulously accounted for all crystallographic features. However, the diffusion rate in noble gases and minerals is so complex, both theoretically and experimentally, that helium concentrations are not considered by a geochronologist to be reliable for any dating implications. Okay, Paul, any thoughts on that?
Yeah. So again, just to kind of backtrack so people are aware what we're talking about here. So the rate group had documented very high concentrations of helium, which is a byproduct of uranium decay, as we've said, in zircon crystals within crustal rocks in New Mexico. And those crustal rocks had a radiometric age by the lead method of 1.5 billion years. And up to 58% of the helium that you would expect from 1.5 billion years of decay is there in the rocks. Okay, so a lot of helium. But Rate commissioned laboratory measurements of helium diffusion out of the zircon crystals. And the measured helium diffusion rates in the lab were so fast that the helium should have completely leaked away within about 6,000 years.
Right.
So that was kind of the claim. So the claim is lots of helium was generated, but it can't have been a long time ago, because otherwise the helium wouldn't still be in the rocks. It would have leaked away. So what Randy Isaac seems to be saying is that the helium diffusion rates that were measured in the lab are not applicable to field conditions because they were measured in a vacuum. That's basically the claim.
Something like that, yeah.
Yeah. So anyway, Russ Humphreys, who was the rate researcher who was responsible for the helium diffusion work, has actually pointed out that external pressure has essentially no effect on diffusion rates in minerals, certainly minerals as hard as zircon, which is a hard mineral. diffusion rates actually vary by less than 1% by removing them from their field context and putting them in a laboratory vacuum chamber. So far from the claim that Randy makes, which was that the actual diffusion rates would be lower by a factor of 1,000 or more. That is not apparently what the experimental data actually shows.
Okay.
It would actually affect the diffusion rates by less than 1%.
Okay. And we can't really verify what Randy claims here because he doesn't give us any citations.
No. So it's
Right.
it's difficult to know where he's getting that from.
Yeah.
And also one other thing I think that's worth just pointing out here is that Russ Humphreys has also talked about the geological history of the site. And I think I'd need to go back and sort of refresh my memory, but I think I remember him saying that in fact the temperatures at the site in the past would have meant that diffusion rates were higher than those measured in the laboratory rather than lower. So you have to also think about the thermal history of the site that the samples have come from. So as far as I can tell, and again, as you say, it's difficult to know because there aren't any citations, so you don't know where this factor of 1,000 is coming from. But it doesn't look as if that's supported by the data.
Okay. Yeah. It sounded good to me. I mean, if it's true what he's describing here, that does sound like a really important flaw, and maybe that is something that future creation researchers ought to be looking at more carefully, this issue of diffusion rate, because it seems to me to be a very critical thing. If the helium concentrations are way more than they ought to be, once you account for all the factors that Randy says you have to account for, then that would suggest that this is not billions of years of radioactive decay. And that's an important thing to know. Yeah.
And just one other point that I'd add here is that obviously rate, and we've said this all along, rate is not a final word. Okay. It's a kind of research in progress. And it would be very helpful if the rate work on the helium, in those samples could be replicated at other sites as well. So maybe looking at other crustal sites, because in effect, the samples came from one location in New Mexico.
Yes.
And it would be quite nice to, be able to show that essentially you can replicate that study in other locations.
Yes, that would be, to me, that would be really important, because I could imagine something weird's going on in one spot on the planet, but that's not a general trend that we see in other rocks. So we would need to test that more broadly.
Yeah.
Good point.
And Humphreys did publish a follow-up paper sometime after the rate project, I think, where he looked at argon diffusion, I believe, and argued that the results from argon diffusion in effect support the conclusions that were drawn from the helium diffusion measurement. Okay. But yeah. So.
All right. Okay, cool. And argon, just so people know, argon is like helium. They are both noble gases. So when Randy here in his article mentions noble gas diffusion, that's what he's talking about. Argon is the result of decay of radioactive potassium. Is that right? Potassium decays into argon. And argon is a gas just like helium is. So that's interesting to note that the argon is also, there's more argon than there should be. Is that the idea?
I think that was the idea. I'd need to go back and look at the paper, but I think that was kind of the idea. Yeah.
All right. Next, he has a section where he discusses the radio halo results. And this I found very unsatisfactory. His conclusion here, they did not recognize is that the presence of uranium seems to provide a reasonable explanation for the source of the polonium and polonium halos with normal decay rates and standard ages of granite. Paul, really?
Yeah. So again, let's just kind of backtrack just to remind our listeners and viewers what we're talking about here. So Rate drew attention to this problem of there being what they call parentless polonium radio halos in particularly granitic rocks, but in some other types of rocks too. And the problem with these parentless halos, now polonium is part of the decay chain of uranium-238. So, so uranium is in effect the source of the polonium. And what Rate were proposing is that this polonium was being separated from the parent uranium as it was forming, being transported by hydrothermal fluids along fractures and cracks in the minerals, where it was concentrating in a new center and then forming a kind of isolated polonium radio halo, one of these so-called parentless polonium radio halos. And their argument was around the very short half-lives of the polonium isotopes. So these are really short half-lives.
Super short.
Super short. And that has implications because in effect what they're arguing is that you have to have millions of years worth of uranium decay, but the short half-lives of the polonium isotopes and the time window in which the polonium radio halos could have formed actually put severe constraints on how quickly that decay happened. And so they're using it as an argument for accelerated decay. That was, if you want the details, go back to our previous episode. So I was completely mystified when I read this response. That was my reaction. So what they did not recognize, Randy says, is that the presence of uranium provides a reasonable explanation for the source of the polonium. Well,
that's what they said.
That is exactly what the Rate group said, is that the polonium radio halos depends on there being a nearby source of uranium in the same rock. So they don't overlook the presence of uranium at all. It is an integral part of the scenario that they're actually proposing. So I was just sort of baffled by that. And I suppose what I wondered is whether Randy had in his mind the old sort of scenario that Robert Gentry many years ago had put forward about the origin of the polonium halos, because Gentry was a creationist who back in the 1980s, 70s and 80s had argued that the polonium radio halos were actually produced by direct fiat creation in the rocks. And so in Gentry's model, there wasn't a uranium source. They were just directly created. But that is not what the Rate group is proposing. What the Rate group is proposing is very, very different from the Gentry model. And I wonder if what Randy's responding to there is Gentry's model, not Andrew Snelling's model and the Rate project's model. So, I mean, that's kind of the only way I can make sense of what's being said there.
I've looked into this before because the halo issue is so fascinating to me. And I've looked into this before trying to find out, all right, well, what is the conventional explanation? Because in the 80s, it was sort of shrugged off by scientists as just a tiny mystery that we'll figure out someday. They didn't have an explanation. And as far as I was able to ascertain, there hasn't really been anybody interested in these questions. They just don't care. No. And so there's sort of these half-hearted little models that say, maybe it's this or maybe it's that. But they don't amount to very much, at least not from my reading. And maybe, again, since I am not a physicist, I don't know. And and if somebody's listening or watching and you know where these models are, hey, leave them in the comments. We want to know. But I don't know that there are any. So for Randy to just sort of drop that and say, yeah, there are these models and they can be explained and not even tell me what they are, I found that a little disappointing.
Yeah.
I wished there had been more.
Yeah.
All right. He then has this section where he talks about discordances that were discussed, that we'd mentioned before. And he concludes here, discordances are not at all unusual. And the source of the discordance is not always understood. But these fail to invalidate the vast amount of concordance. Furthermore, no argument is presented why differences of 15% in the that's basically where the dates vary, right? 15%.
Yeah.
No argument is presented why differences of 15% would justify the claim that radioisotope dating is in error by a factor of 1 million or more.
Yeah.
The end.
Right.
Yeah. Thoughts on that?
Yeah. So again, just to kind of remind our viewers and listeners, when radioisotope ages on the same rock sample, multiple radioisotope measurements on the same rock sample agree with one another, they are said to be concordant. And when multiple radioisotope measurements on a single rock sample disagree, they are said to be discordant. That's what we're talking about when we talk about concordance and discordance. And Rate actually undertook or obtained radioisotope ages from a number of different radiometric dating systems on a number of rock units. And they found that discordance was normal. It was common. And one of the things they also noted, which is very interesting, and remember they used 4 radiometric isotope methods on each of the samples that they studied, so 4 different methods, and they found that there was a pattern to the discordances. So isotopes with longer half-lives tended to give older ages than isotopes with shorter half-lives, and alpha decayers tended to give older ages than beta decayers. So there was this systematic sort of pecking order, if you like, of dates on the same rock units. And what Randy basically says is that, he acknowledges discordance is not unusual, and that often we don't really understand the discordance. So that's important. But then he says that doesn't invalidate the vast amount of concordance. And again, there's no citation. So I have some questions, and I think it does raise an interesting question, which is how common is concordance? What systematic studies have ever been done to demonstrate how common concordance is? How often are multiple methods, but by which I mean more than 2, used on the same rock units? How often is that done? And what do we see when we look at the data? And Randy doesn't cite any literature. He just kind of makes this claim about vast amounts of concordance. I don't know that we actually have good answers to those questions. We actually have a couple of students. I have a couple of students at the moment working on a very interesting project, which I can't say too much about at the moment, but it may actually help us to answer some of those questions.
That'd be good.
about how common concordance is. So that's something to watch out for. It's a paper that hopefully we can present at the International Conference on Creationism next year.
Excellent.
So I think those are important questions. I just think we don't have enough data. And the study that Rate did, where they systematically looked for patterns of discordance, they found that discordance was very, very common. It was basically, typical in the rock units they looked at. Now, you could argue they only looked at a limited number of rock units, and the rock units that they looked at were in some ways not representative or atypical, but that needs to be demonstrated, right? So we need to understand what the data actually says. The other comment I just make is that Randy talks about differences of 15%. Actually, some of the differences between results of radiometric dating on these rock units was way above 15%. Some of the discrepancies were much, much bigger than that. So I think that tends to minimize the problem of discordance in many cases.
I thought it was weird.
So, yeah.
I thought it was weird that he, on the one hand, he doesn't recognize the systematic differences, the systematic errors, that if you use method A, it's always going to be older than method B. That tells me
almost always anyway.
Yeah.
It's
always. On average will usually be older than method B, something like that. He doesn't seem to grasp that. So I thought that was, to me, the systematic error issue is the most important part of this discordance, because as he says, as you know, as I know, measuring these complicated things is complicated, and stuff happens, and it doesn't surprise me that you get slightly different answers every time. But I would expect those kinds of differences to be random. I would not expect it to be always in favor of one method over another. That's weird. He doesn't really address that.
No, and that's the crucial point, isn't it? It's not the fact of discordance that is so interesting. It's the pattern in discordance. And when scientists see patterns, that kind of cries out for you to explain the pattern.
Right.
What is going on there when you see
what's causing this? Yeah.
Yeah. And that's not something that's really addressed in this essay. So.
Right. All right. So those are three things that he mentioned. He's got other comments as well. Things that we haven't talked about from Rate, which is the carbon-14 material. Carbon-14 is the radiocarbon dating, carbon, that sort of thing. That's a complicated, different sort of thing altogether. That's not part of dating rocks. It's part of dating organic remains. And I think we've mentioned it a couple of times, but I don't think we've really dived too much into that. So we can come back to carbon-14. It really needs. It almost needs a whole series of episodes on its own, actually. It does, because it's a complicated subject, and it's been addressed on many different occasions by many different creationists. Rate contributed one small bit, very small bit. So it's almost not worth fussing about. But he has a long section here on carbon-14. So I don't want to give people the idea that we're cherry picking. He has other things to say. It's true. So Todd, if you're interested, you should check it out.
Yeah, and that kind of brings us on then to what he says at the end of the paper.
Okay, why don't you read that for us?
Okay. So this is the final paragraph, and I know you're keen to make some comments in response to this. So, so this is not dealing so much with sort of scientific specifics. This is more to do with a kind of philosophical and methodological kind of issues here, I think. And so it says this: the ASA does not take a position on issues when there is honest disagreement among Christians, provided there is adherence to our statement of faith and to integrity in science. Accordingly, the ASA neither endorses nor opposes young Earth creationism, which recognizes the possibility of a recent creation with appearance of age, or which acknowledges the unresolved discrepancy between scientific data and a young Earth position. However, claims that scientific data affirm a young Earth do not meet the criterion of integrity in science. Any portrayal of the Rate Project as confirming scientific support for a young Earth contradicts the Rate Project's own admission of unresolved problems. The ASA can and does oppose such deception. Wow, I mean, that's quite a way to end that little review article.
Yeah.
So, yeah, what do you make of that, Todd?
Well, to put it in different words, it's okay for you to be a creationist as long as you don't claim to have any science in favor of your creationism. And the way he defines science, the way he uses science in the essay is clearly, widely accepted, generally recognized conclusions and results. that have been peer-reviewed and accepted by the majority of scientists. So basically, anytime we talk about any sort of scientific result in favor of creationism, it is, I guess, deception by definition, which I have a real problem with. I mean, how in the world can we find out answers to these questions, right? If we're not allowed to work on the science. I don't know. If I'm allowed, if it's okay for me to say there's a great deal of scientific questions which are unresolved in young age creationism, which I think is true, then I can't work on them? Is that right? I'm a liar if I try to work on these things? I don't think that makes any sense. And especially when, I look through the review and I find these open questions where I feel like Randy didn't treat him very well. I mean, he didn't. Let's not say it that way. Let's say it that Randy did not seem to grasp the important nuances that the RATE project was trying to emphasize, or at least he doesn't address them. And so, yeah, I don't know. I don't know what we're supposed to do. We're just sort of, we're stuck. We can't talk about the science without being liars and therefore not welcome at ASA.
It's very unfortunate.
I'm lost. I don't know what we're supposed to do. So I guess, they say they don't have a position on the age of the earth. And I've heard them say that recently. I've heard folks from ASA say that recently, and it shows up in print pretty regularly. But at the same time, there is sort of a de facto pecking order there. And again, it's, I think it has a lot to do with the history of the ASA and the CRS and the personalities involved. But I think it's really unfortunate to say that someone is just flat out lying.
Well, it's a
bar of evidence.
It's a science showstopper.
Yeah, it is. It's
a science showstopper because, in effect, what they're saying is, you can be a young Earth creationist, but the moment that you say, "Here's a piece of evidence that I think supports my model," that automatically makes you a liar, and so you're ruled out of the discussion from that moment on. That seems a very strange way to proceed to me. But.
And it would seem to me incumbent upon the accuser of the liar, to show that there is indeed a lie at play, right? I think people can be, even if young age creationism is wrong, people are sincerely convinced that the way they have read the science is the correct way to read the science. So even if I grant, which I don't necessarily do, but even if I grant that there's no scientific evidence for creationism, which is crazy, but let's say I do say that, that doesn't mean that the person who says otherwise is a liar, right? I say there's no way to fit the Bible with evolution.
Yeah.
Right? But there are lots of people who totally disagree with me. Passionately disagree with me. And I don't think they're liars because they disagree. I just think they're mistaken. Genuinely, sincerely mistaken. And I think to immediately jump to a judgment of sin is really not where we ought to be going.
Yeah, that's good. Well, that kind of brings us to another thing that we wanted to talk about today.
Right.
Which concerned outstanding questions that kind of arise from the RATE project. Because the RATE project was, as I said earlier, was never meant to be a final word. It was really establishing a research program.
Right.
And that research program is still ongoing. I mean, there's still, people are still doing work that kind of builds on what the RATE project did. And there is a lot more still to be done. That's for sure. And there were some really interesting sort of issues that arose from rate that I think we should just sort of touch on. The first one concerns the mechanism. Okay, so if there really was this episode or episodes of accelerated nuclear decay, are we able to say anything about the mechanism? How did that happen?
Right.
And how does that relate to other aspects of flood models? Do you want me to have a go at that, or do you have some thoughts about that, Todd?
I don't know that I have thoughts about that. I would say that what we're going to talk about here is really important, because I think a lot of folks that I talk to, just not scientists, but just, the regular people in the pew at the church, sometimes they seem to portray rate as solving the problem. Rate has settled the issue. And that is literally not even how rate portrayed the question. And I'll grant Randy the optimism with which the rate folks presented their results makes me a little uncomfortable. It's a little oversold, maybe. Maybe. I still think there's some really important things at rate. So don't think that I'm saying that they're bluffing you or lying or anything like that. I don't think that's true. Yeah, it's important to understand that rate, the scientists involved in rate by themselves acknowledge that there are open questions. And like you say, The first one is mechanism. How in the world would this happen? And is this just something where you just sort of have to shrug and say, well, God did a miracle? Or is there something that we can say about it?
Yeah.
What do you think, Paul?
And well, the first thing I was going to say is that the rate group don't hide these potential objections from their, from people who are reading their work. If you read the second volume that came out, it very clearly sets out what some of the problems and issues are and potential avenues of further research. And it's even included in the popular book, Thousands Not Billions. You can read at the end, here are some outstanding issues and questions that still haven't been resolved. So it's not like anybody's sort of hiding this.
Right, right, yeah.
Yeah, on the question of mechanisms, I mean, that was really Eugene Chaffin's sort of main contribution to rate, was to think about the theoretical physics behind what the mechanisms might be and how that might work. And it's all very complex. It involves all kinds of things like nuclear forces and different dimensions and string theory and all kinds of things it's all above my pay grade, so I don't understand any of that. And he's continued to publish papers, looking at theoretical mechanisms. So, he's still quite active sort of, publishing on that area. And I think it's interesting. I've actually not sort of delved into that to a great degree because I am not a physicist of any kind, right. And I don't understand that literature. But there are these various scenarios that have been proposed to explain that. And in terms of how it fits with our existing flood models, I think there are some interesting questions there. For example, we know that one of the the great driver of geological processes is heat. And as we're going to come on to, radioactive decay generates heat. And I wonder if that's all sort of part and parcel of whatever the mechanism was that God used to bring about the global flood. So there's lots of interesting questions, but I don't have any great insight because I feel very quickly out of my depth when I'm reading about the physics of it.
Right. But I would also mention here the systematic error in the dating methods that we've been emphasizing. That really does suggest there is something physical.
Yes.
Miraculous, probably, too, but also physical, that God modified something that caused these rate discrepancies to happen in a systematic way.
Yeah. Yeah.
So I don't think searching for a mechanism is futile.
No. So it looks as if whatever happened caused certain radioactive clocks to run faster than others. Right. That's why you get the systematic discrepancy.
Exactly.
That's why the rate group think there's a clue there in the systematic discordances to what's actually going on. So even if ultimately at bottom there's some kind of miraculous, adjustment of physical constants or parameters by God, I think you may still be able to infer some interesting things about exactly how that happened and, what was involved because of these patterns. So, yeah. I guess that also leads on to, another question, which is, what is the relationship then between radiometric time and real time?
Yes.
Because if these clocks were essentially running faster during the flood, might it be possible to recalibrate radiometric dates so that they actually align with real time during the flood?
Yeah.
Is that possible? And that is really interesting because you could then have a way of dating events during the flood.
Right. Yeah. To me that is sort of the holy grail here, right? Figuring out, if some scientist says this was dated with uranium lead dating and it came out to be, 250 million years old, I throw it into my recalibration equation and it tells me, that happened on day, whatever it is, 173 of the flood. And then I think, great. I've actually asked Andrew Snelling and Steve Austin this question. I think I asked John Baumgartner too. Because I ask everybody that I know, every geologist I know, I want to know how to do this because this seems like the really important. And they tell me it's all very complicated. They're not sure they can do that, right? So I don't know. I still think if there's a change in the universal constants, then it stands to reason it ought to be universal, maybe? I don't know. And so we ought to be able to recalibrate things, but maybe that's a very long way off.
And because of the systematic discordances, it probably would have to be a different kind of calibration for each of the different radiometric dating systems.
Right.
As well.
Exactly.
So it is complex. But who knows whether some bright young person or group of scientists in the future is going to be able to work that out. Who knows? It is interesting because despite all of those discordances and the problems, clearly with discrepancies, there is a trend, right? So remember, older rocks do tend to give older radiometric dates. There is a wonderful graph in this one here, in Russ Humphrey's. This is actually in the first rate book.
Mm-hmm.
And it's on page 342. And what this graph shows basically is that he's got about 300 radiometric dates that deviate from what the actual date is thought to be by at least 10%. So these dates were chosen because they are discrepant dates.
Okay.
And yet you can still see this clear trend where older rocks tend to give older ages and younger rocks seem to give younger ages.
Yeah.
So that is interesting. There is a trend, and it means something. The dates are not meaningless. So, we need to be able to understand those. Couple of other issues that kind of arose. One is what you might call the radiation hazard problem.
Right.
So, if there was an episode of accelerated decay during the flood, and we've got, Noah and his family and the animals on the ark, how were they protected from the harmful effects of the radiation that was produced? This is another question that kind of comes up at the end of Rate.
And
there's silence.
Yeah. Do I have an answer? I don't have an answer.
No.
thinking through that, you think about people who've had x-rays, you know how it goes, right? They, especially if they're like a dental x-ray, right? They come in and they put that heavy lead apron over your chest, right? And then they line up the camera, and then the technician leaves the room. Right? Radiation is not good for you, right? So a couple of x-rays in your lifetime, that's probably okay. But you don't want to needlessly expose yourself to radiation, because it causes mutations and it can cause cancer. And if you get a big enough dose of it, it can literally fry your body, right? A microwave is heating things up. If there's a case of a Russian gentleman who, it wasn't exactly radiation, but he was exposed to a particle accelerator, and it burned right through his brain.
Wow.
So yeah, radiation's not good. And if you cram 4.5 billion years of radiation into 1 year, how in the world does anybody survive that? Especially, here's the other problem. We have radioactive stuff in us, right? We have small amounts of radioactive elements because they just occur naturally. And so things like potassium in our body, there's going to be in everybody's body just a very tiny, not terribly dangerous, but a very tiny amount of radioactive potassium that will decay into argon. Carbon, there's carbon-14 in us. Now, again, carbon-14 is a complicated thing. There might not have been as much carbon-14 in Noah as there is in us, but there are other elements in our bodies that could have been also radioactive as well. And so if they start, decaying immediately during the flood, that's not good either. So
yeah.
This is an important one.
Yeah. So, you could imagine that Noah and his family and the animals are protected to some extent from radiation in the rocks by the floodwaters themselves. That, it may provide some measure of protection, perhaps. But like you say, that's not going to help you with the radioactive potassium that's in your actual body. So, is it possible that before the flood, much less radioactive material was incorporated into the bodies of the pre-flood people and animals? I don't know, but it's possible. That's another area that they suggest needs more research. But the biggest one, I guess, probably one of the biggest problems, and this is the one that I know lots of people kind of latch onto, is the heat problem.
Mm-hmm.
So we know that radioactive decay generates heat. And if you compress a lot of decay into a very short period of time, then you get lots of heat.
A lot of heat, right, yeah.
And we're not talking about a small amount of heat. So, if you cram hundreds of millions of years worth of decay into 1 year, I think the rate group estimated that you'd raise the temperature of the crustal rocks to about 22,000 degrees Celsius. So
that seems hot.
This is hot. I think it's nearly 4 times as hot as the surface of the sun. So
okay, so this would literally melt the planet.
Yes, it would melt the planet. So that is not an insubstantial problem. And in fact, during the flood, accelerated nuclear decay is probably not, it's not the only heat source. So you've got the heat from catastrophic plate tectonics and cooling igneous bodies and maybe meteorite impacts. There's all kinds of other inputs of heat. So the heat problem is a big one. And, one of the things the rate group points out is that we know that temperatures never got that high, partly because, we still have a planet, but we can put some constraints on the temperatures because of those fission tracks and radio halos.
Yeah.
Because when those rocks get above 150 degrees, those features in the rocks get thermally erased.
Okay.
So we know that since those halos formed, since those fission tracks formed, the rocks did not get above 150 degrees. If those features are still present. So it's a huge problem. Now, Creationists have been publishing on this since the Rate Project reported. My colleague in Biblical Creation Trust, Dr. Bill Warwicker, has actually been publishing a series of papers in the Answers Research Journal where he's trying to quantify more accurately, more precisely, all of these different heat inputs during the flood. And people have proposed possible mechanisms, for heat dissipation. I think Russ Humphreys in the Rate volume and in papers subsequently has tried to explore a kind of cosmological cooling mechanism involving the expansion of space. And, again, it all starts to get, the physics starts to get very, very exotic.
Yeah, definitely.
But then I kind of always think, well, if the conventional cosmologists can appeal to exotic physics and they start, introducing inflation to solve Big Bang problems, why can't we explore some exotic physics? So, I don't begrudge the physicists doing that, but it is a problem, and it's a big unresolved question that arises from Rate.
Yeah, and I want to bring up here. This was something that Randy Isaac also included in his article.
Yeah.
And again, I feel like that's when he's right on the money. So what we have then, if we sort of step back here, we've got evidence that radiometric dates sort of line up with what we would expect from other age indicators, such as the geologic column itself. So older rocks that appear older have older dates. But we also have these weird, and we have evidence that there actually has been radioactive decay, the halos and the fission tracks. But there are also these weird issues, such as the helium and the plutonium halos, which suggest that something odd is going on. Polonium halos. Sorry. Polonium halos. See, I'm not a physicist. Polonium halos and the argon and helium concentrations would suggest that something really weird is happening. And so one answer is that, those issues are unimportant and the Earth is really old. The other answer would be, well, it looks like there's been an accelerated decay and the Earth is young. Either way you go doesn't strike me as terribly entirely satisfying at this point because of the heat problem. And
yeah,
I mean, yeah, and I've mentioned it to Andrew Snelling before, and he said, well, we know it's not higher than 150 degrees, like you say, because we still have halos. And I think, well, that doesn't answer the problem of where the heat went, if there was accelerated decay. So these are questions we're going to want to address on future episodes as we start talking to some of the actual individuals in the Rate Project.
Yeah. And we need to draw this episode to a close, but there is one question that I do kind of want us to end on, really.
Okay.
And it kind of arises from something that Randy says in his article. He says that he talks about Rate's own admission of unresolved problems.
Mm-hmm.
And that seems to be a big problem for him. This model that Rate have put forward has some unresolved issues. Does that mean that Rate is not a good answer to the problem of radiometric dating? If it has unresolved problems, does that mean that we kind of just have to dispense with it entirely because there are some unresolved issues?
Right. So I guess the question there is, what does it mean to be a good answer, right? So in the sense that it provides a satisfactory answer to every outstanding problem, then obviously no. But I would argue no science can do that. because that would imply that you are omniscient or something, that there is no anomalous data. There's always anomalous data. That's just how science works. There's always going to be something that's unexplained, and it's in some sense up to the community to decide when something is really important that it can't be ignored anymore. Now, on the other hand, I think that rate has provided a lot of really interesting pieces of data that do, as you say, set up an alternative research program on radiometric dating. And those studies, I don't think we should just say, well, who knows? The Earth looks old. That's the end. They raise really important questions that, again, maybe because of my inexperience here, I don't know about answers that have been given. But it seems to me there's plenty here worth exploring. So I guess I don't want anybody to come away from this thinking that rate has solved all the problems. They have not. By their own admission, they have not. Yeah. But I also don't want people to just shrug it off and say rate was a big nothing, big disappointment, because it didn't solve, say, the central question of how do I recalibrate radiometric dates to flood dates? Okay. That's a hard problem.
Yeah.
And I don't think that disqualifies rate from being important.
Yeah.
It just has to be communicated in a very nuanced and careful way.
Sure. And I think as long as it gets us doing more science, collecting more data and doing more experiments and, testing ideas, as long as it's productive scientifically, that's the important thing, I think. For me, that's, yeah. Okay, we should finish there because we've gone quite long on that. But
yep,
yeah, that's great. Now we don't know what's coming up next in a fortnight's time, so do join us for that. Remember, you can check us out at coresci.org/podcast. That's coresci.org/podcast. All of the information about the podcast, including show notes and where you can access the podcast, is available there. And of course, we are on YouTube. Do send us your comments and questions and feedback. We enjoy hearing from all of our listeners and viewers. You can do that by email at podcast@coresci.org, or you can leave comments on our YouTube videos. Do remember to like this video, share it, with others, recommend the podcast to your friends, spread the word, and subscribe, and hit that notification bell, and then you'll hear when we post a new episode. And as always, there are two organizations that sponsor the podcast: Core Academy of Science and Biblical Creation Trust. If you want to check out Biblical Creation Trust, you can go to our website, biblicalcreationtrust.org, and there is a donate button on the homepage, which will take you to all of the options to drop us a donation. And we do appreciate it. And Todd, tell us all about Core Academy of Science.
You can find Core Academy of Science on the web at coresci.org/connect. That'll be a place where you can find links to important content we want you to check out and basic information about the ministry. That'll also take you to the main homepage. And if you go to coresci.org/donate, that will connect you with our information on how you can give financially to support the work of our ministry and the work of Let's Talk Creation podcast.
Fantastic. Well, that's it for this time, and we'll see all you guys in another couple of weeks. We'll see you then.
All right. See you then.
Thanks for listening to this week's episode of Let's Talk Creation. If you have questions, send them to podcast@coresci.org. That's podcast@coresci.org. And be sure to let your friends know about Let's Talk Creation. And check us out on social media. Thank you.